Hello, welcome to another episode of Chemistry is Easy with Mr. Jesse. For this tutorial, we will cover the following objectives. Compare the general formula of alkenes and alkynes with those of alkanes, and name an alkene by examining its structure. Alkenes are unsaturated hydrocarbons that contain at least one or more double covalent bonds between carbon atoms. So those are alkenes. So if we find a double bond between two carbon atoms, that automatically makes that hydrocarbon an alkene. So here are some examples of alkene. We have the ethene. So if you notice, ethene is actually an alkane that contains two carbons, and these carbons are bonded by a double bond. We also have here a propene, and propene simply means that it is an alkene that contains three carbons, and in two of those carbons we could find a double bond. We also have here one butene and two butene. Now look closely into the difference between those two alkenes, and we will be discussing that as we move on with our with the next few slides. Now remember, if you notice, we do not have a methane for alkene, so the least or the smallest number of carbons that we can have in an alkane would be 2, and therefore we start with an ethene. Remember again, there is no methane if we talk about alkene. Comparing the general formula for alkanes, alkenes, and alkynes. Alkanes have the general formula of CnH2n plus 2. So if we have C3, meaning 3 carbons, we will have C3H2 times 3 plus 2, which gives us C3H8. Moreover, alkanes will have the general formula of CnH2n. So if we have 3 carbon atoms, we will have C3H2n, so 2 times 3, which will give us C3H6. And lastly, for alkynes, we have CnH2n minus 2. So if we have 3 carbon atoms, we will have C3H2 times 3 minus 2, which will give us C3H6 minus 2, which will then eventually give us C3H4. Naming of alkenes is very similar to the way alkanes are being named, but instead of having an ane as its suffix, alkenes usually end with an ene. So we have ethene, propene, butene, pentene, hexene, and so on and so forth. Now, when 4 or more carbon atoms are present, specify the location of the double bond. This is done by numbering the carbons in the parent chain, starting at the end of the chain that will give the first carbon in the double bond the lowest number. So if we are going to look at this example, there would be no such thing as a 3-butene, or naming this alkene as 3-butene would be wrong, because we have to number the carbons such that the double bond is closest to the first carbon. So if we could find the carbon at this location, we do not call it 3-butene, but instead 1-butene. 1 meaning we could find the double bond between carbon 1 and 2, and we would assign the lowest number to that of the double bond. So we say 1-butene. We'll look at the second example. So we call it 2-butene, mainly because the double bond is connected between carbons 2 and 3, and then we have to assign the lowest number to that double bond, so we will have 2-butene. Name this alkene. So to do that, we have to count the number of carbon atoms that we have in this alkene. So we have 1, 2, 3, 4, 5, 6, 7. So an alkene that contains 7 carbon atoms is a heptene. Hept meaning 7. Now we also have 2 double bonds in this alkene. We have this double bond and another double bond. So we have to assign a number to these double bonds. So to do that, we must also assign a carbon or the number to the carbon wherein the double bond is closest to the first carbon. So if you notice, guys, or if you notice, we can find the first carbon by numbering this way. We can find the first carbon in carbon 3 and the second carbon in carbon 5. However, if we start counting from this carbon here, so we call that carbon 1, 2, 3, 4, 5, 6, and 7. The first carbon is the first double bond is associated with carbon 2, while the second double bond is associated with carbon 4. So this is actually the upper way of numbering the carbon atoms is more proper compared to the other one, the lower portion. Then we will say the name of this alkene would be 2, having said that the first double bond is connected with carbon 2 and the second double bond is connected with carbon 4. It's between carbon 4 and 5, so we say 4 comma 2 hepta. Now since we have 2 double bonds, so we will call it heptadiene. The di here indicates that we have 2 double bonds. So this means that if I will have another double bond between carbons 7 and 6, then the proper name would be 2, 4, 6 hepta, and instead of saying di, since there are 3 double bonds, we call it heptatriene. Triene means 3 double bonds. So we have heptatriene. When naming branch chain alkenes, follow the same rules as for alkanes with 2 exceptions. The first exception is that the parent chain is always the longest chain that contains double bond, whether it is the longest chain or not. So if we look at this example here, our longest chain would actually be 1, 2, 3, 4, 5, 6, 7, 8. It is composed of 8 carbons. However, as the first exception says, the longest chain must contain the double bond. So instead of having 8 carbons as our longest chain, the parent chain should be this. Let me just change its color. That's 1, 2, 3, 4, 5, 6. So that is an alkene that contains 6 carbon atoms, which we will call, or which is called a hexene. That is our parent chain for this alkene. And here is the second exception. The position of the double bond, not the branches, determines the numbering. So since having determined that our parent chain is actually this, so this will be our parent chain. Numbering the carbons is determined by the position of the double bond and not the branches. So we could see here this branch. This would not be the basis of our numbering, but instead this carbon. So to properly number this carbon, we will have 1, 2, 3, 4, 5, 6. Even though that this branch here is actually closer to carbon 6. Again, for this exception, the position of the double bond, not the branches, determines the numbering. And so now let us name this alkene. This will be our parent chain here, and that is composed of 6 carbon atoms, so we will have a hexene. we have a hexene. Now with that parent chain, we have a substituent over here, which is an alkyl group composed of 3 carbons. This is actually a propyl. And we also have an alkyl group that is attached to this carbon over here, and we call this alkyl group that is only composed of 1 carbon as a methyl. Alright, now we have to determine the number, we have to assign the number to our parent chain. So this is carbon 1, since it's actually closest, since the double bond is closest to it. This is carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6. So we have here methyl being connected to carbon 4, and our propyl is connected to carbon 2. Now recall from naming of alkanes that we have to arrange the alkyl groups in alphabetical order. So we should name this as 4-methyl. Alright, that's 4-methyl, 2-propyl, and we have to determine the location of the double bond for our hexene, and we can find that double bond between carbons 1 and carbon 2. So we will say 1-hexene. In fact, the full name would be 4-methyl, 2-propyl, 1-hexene. Having covered the following objectives, this concludes our tutorial. Once again, chemistry is easy with Mr. Jesse.